The formula you need to convert from degrees to radians and radians to degrees is found on your formula chart, but here's the way that it works. Basically, you are going to take what you are converting, which is pi, and I'm going to write it as pi over 1, and you're going to multiply it by a multiplier, 180 over pi. Now, I know to go from radians to degrees, this is the one I want, 1 because it's on my formula chart, and 2 because the pi's will cancel out. And 180 divided by 1 is 180 degrees. This is also a fact you should probably know, that pi is equal to 180 degrees. To convert 70 degrees to radians, you're just going to use that same scalar, but you're going to use it backwards, which means the pi goes on top and the 180 goes on bottom. Now this time, nothing necessarily cancels out, but I do notice that both of these terms are divisible by 10. So I can cross off the 0, aka divide both of them by 10, so that we have 7 pi divided by 18, and that's honestly as simplified as it gets. That's the radian measurement. To solve the following equation, we're going to round to the nearest hundredth. Remember, we're trying to get this x by itself. So to do that, we're going to multiply 150 on both sides. That would be 150 times the sine of 32 degrees equal to x. So that is something we can type in our calculator. Now I need you to double and triple make sure that you remember to check the mode of your calculator, because there will be problems that you might be using radians and there will be problems where you might be using degrees. In this particular problem, we are using degrees, so we need to make sure our calculator is in the correct mode. Once it's in the correct mode and we type it in, however, we'll find out that x is equal to 79.49. Again, I'm not showing the calculator steps, so if you need help with how to do the calculator parts of this, please come ask me in class. We're going to try to find tangent of theta given that sine of theta is 5 over 13. Notice they didn't necessarily give us a theta, so I'm not trying to find the angle measurement here. I'm just trying to figure out what the tangent of that angle would be. And that's plenty of information for us, because if we have this angle theta, we know that sine is the opposite over the hypotenuse. Okay, the reason I know this, just for good measure, is SOHCAHTOA. So sine is the opposite over the hypotenuse. And since I now have this triangle that looks like this, I know with Pythagorean theorem that this other side, we'll call it a squared is going to be equal to 13 squared minus 5 squared, hypotenuse minus other side length. And if you do that math, that's 144, which also then means that a is equal to 12. So I can replace this a with the number 12. So if I wanted to find tangent, tangent is just the opposite over the adjacent. So the tangent of theta should be equal to the opposite side length, 5, over the adjacent side length, 12. 5 over 12. This next problem, we're going to find theta this time, given that cosine of theta is 1/2 and sine of theta is less than 0. Now, either by remembering the table that I've had you memorize in this class or looking at your formula chart, you'll remember that the cosine of 60 degrees is equal to 1/2. That's also pi over 3. It doesn't say what we have to be in degrees or radians, so we'll do both. So we know our angle measurement. We just need to figure out which quadrant we're in. So we remember from the quadrants that this is all star trig class. And if cosine is positive, because it's 1/2, that means it's going to be in one of these two quadrants. But we also have the fact that sine is less than 0, which means it's in one of these two quadrants. That's where sine is less than 0. So obviously, this means that our angle is going to be in quadrant 3. Now, if we were to draw a 60-degree reference angle in quadrant 3, this is 60 degrees. That's cool, great, awesome, but really, I need this whole angle here. So that angle is 60 degrees less than an entire wrap around the circle, which means that angle is 300 degrees, or quite simply 5 pi over 3, which again, you can check on your formula chart. This next question asks, what is the amplitude of the following cosine function? Remember that amplitude means that it is the distance from the center line to the max or center line to the min. So if we look, we have a center line of this graph here at 0. Hooray, that's my center line. And I also have maxes and mins at these different points along the graph. If we just focus on this very first one, what is the distance from that center line to the max? Yeah, the amplitude is just 1. Very simple. This next problem says to find the missing angle. Now this is really a geometry question, but it does involve itself in our trig world because we have 2 of the 3 angles. We just need to know what this one is. But if we remember the simple fact that all of the angles in a triangle have to add up to 180 degrees, we know that we can find that missing angle just by taking away the other 2 angle measurements from 180 degrees. Beep, 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 you type that in a calculator, do that in your brain, you'd get 145 degrees for that missing angle. To find side length A and then go ahead and find side length B, we're going to employ the law of sines. Now, I know I want to use the law of sines because I have both the angle measurement and its opposite angle, which means I'd have one of the true pairs of the law of sines. You can look on your formula chart for the law of sines, but it says that the sine of angle A over side length A should be equal to the sine of angle B over side length B, which is also equal to the ratio sine of C over side length little c. So, once we have this angle C and its side length, we're able to use the law of sines to find our missing side lengths. So if I were to set the first one up to find side length A, we would do the sine of 63 degrees divided by 12 should be equal to the sine of 42 degrees divided by side length A. Well, that's a proportion we can solve. We would cross multiply 12 times the sine of 42 degrees equal to A times the sine of 63 degrees. Divide by sine of 63 degrees. We would say that A is equal to 12 sine of 42 degrees over sine of 63 degrees. And if we type that into a calculator and press enter, making sure our calculator is measuring in degrees and not in radians, we would get, rounding to the nearest integer, that A is 9 meters in length. Awesome. So now that we found side length A, I'm going to go ahead and relabel my graph, or my table, my figure here. It says to find side length B, which means we are looking for that side length. Now I can't necessarily use the law of sines until I found that missing angle. But again, just kind of like that problem we did before, if we're trying to find this missing angle here, we just have to take 180 degrees and subtract the other 2 angles that we have, which means that that angle B is 75 degrees. So when I set up my law of sines again, I would still use the the sine of 63 over 12 equal to the sine of 75 degrees over side length B. I like to continue to use the one given to me, the 63 and 12, as opposed to the one I found, just for rounding errors. And if we solve for B, we would cross multiply and then divide. So we'd have B is equal to 12 times the sine of 75 degrees, all divided by the sine of 63 degrees. And beep, 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 if you type that into a calculator and round to the nearest integer, you get 13 meters. And so voila, we have all of our side lengths, and technically we solved the entire triangle. I'll go ahead and write that in because it looks nice whenever the whole thing is labeled. Nice. Now what if I need to find the altitude, okay, or the height of a triangle, and this is the information I'm given? Well, my first instinct when I see that I'm trying to figure out this triangle is I see that to use the law of sines, I would need this angle measurement C. Okay, working backwards, I can tell that I'm going to be able to find the other 2 side lengths because this makes a 90-degree angle, and so does this one. So unlike doing 180 minus the angle measurements, you can do 90 minus those angle measurements to be able to figure out what those 2 angles are, which means angle A, what we'll call angle A for this triangle, is 58 degrees, and angle B is 42 degrees, which means then that angle C, doing 180 minus 56 minus 42, is 80 degrees. Okay, cool. I'm going to start using the law of sines here. I would do the sine of 80 degrees divided by 10 miles is going to be equal to, and you just pick one of the two sides to find. I'm going to pick angle B, or side length B, sorry. So I'm going to do the sine of 42 degrees over B. We solve for B by cross multiplying and then dividing to get that B is equal to the 10 times the sine of 42 degrees over sine of 80 degrees. And beep, 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 type it on our calculator. We would get 6.795. I'm going to keep 3 decimals for now. I know it says round to the nearest hundredth, but because I'm going to use that number, I'm going to keep more decimals in the middle of the problem. Because this is not our answer. That is this side length, 6.795 miles. We are still trying to find the altitude. But if I were to redraw this triangle here, and I'm going to highlight it in blue. I'm going to redraw this triangle based on what I know so far, just to make it maybe easier for you guys to see what I'm doing. So we have this 90-degree angle. This is 58 degrees. This is 6.795, and this is the angle H. Well, if we think about just plain regular trig, we want to know the opposite and we know the hypotenuse, which means that I'm actually going to be able to just do simple sine of 58 degrees is equal to the opposite, H, over the hypotenuse, which is 6.795. H this time does not stand for hypotenuse. Remember, it stands for the height, or this H value in the altitude of this triangle. So if I solve for H, I just have to multiply by 6.795 on both sides, which means I really just need to figure out what 6.795 times sine of 58 degrees is. And if you beep, 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 type that in a calculator, you get 5.76 miles. That's the height of that triangle. This next problem starts our quarter 4 calculus problems. The first problem here says, what is the limit as x approaches -1? So if we're annotating this question here, -1 is here on the graph. When we're doing limits, we're looking barely on the left and barely on the right of that along the graph. If those arrows are pointing towards the same number, which they are, our limit is that number that they're pointing to. But, and like we will see at 2, if those arrows are pointing to two opposite numbers on each side, meaning the left side is 5 and the right side is 2, those are not the same, which means this limit does not exist. Now we're sticking with the same graph here, but we're going to use the 3 steps of continuity to determine if f of x is continuous at x equal to -1. So again, we're checking here on the graph. The first step of continuity is to decide that the function is defined. Can I give a value for f of -1? Yes, there is a closed dot here at 0. So f of -1 is 0. Cool, great, awesome. Number 2 is to show that the limit exists. So to do that, I have to check both side limits. Now, we technically did this in the problem right before here, but if we look on the left side of -1, the limit is 2. And if we look on the right side of -1, from the positive side, that limit is 2. Therefore, the limit itself as x approaches -1, because both arrows went the same direction, is 2. Third and final part of continuity just wants to decide if the answer you got in part 1 and part 2 are the same. And very obviously, the limit as x approaches -1 of f of x is not equal to f of -1, because we got 2 and we got 0. Those are obviously not the same number. Therefore, f of x is not continuous at x equal to -1. If they happened to have been the same number here, then you would say it is continuous at x equal to -1. What is the equation of the horizontal asymptotes of this graph? My friends, when we are talking about horizontal asymptotes, there is 3 acronyms that we need to remember. That is Bobo, Botan, and Betsy. When we remember these 3, it'll tell us how to find the horizontal asymptotes, which is the limits as we head to infinity for this graph. Now, obviously, for this one, these are the same. Bottom is equal to top, which means we divide the coefficients of 4 and 1. My horizontal asymptote is at 4 divided by 1, or 4. Same question, but new graph. Again, Bobo, Bot, and Betsy. We see on this one that we have bigger on the bottom, because this is x squared on bottom and x on top. That means it's Bobo, bigger on bottom, which means that the horizontal asymptote is 0. Next question asks you to take the derivative of the following. Now we're employing both the power rule, some trig rules, and the sum and difference rule to be able to do each of these individually. F prime of x would be equal to, use the power rule. 5 times 3 is 15. 3 minus 1 is 2. The derivative of negative sine is negative cosine. The derivative of tangent is secant squared of x. And the derivative of negative 4x is just negative 4. And there we have our derivative. The next problem says, what is the average rate of change of the function below on the interval from 3 to 5? Let's try to really hard remember that the average rate of change formula is really just the slope formula, which is the output from the second number minus the output from the first number over the second number minus the first number. It is just a fancy way of doing y2 minus y1 over x2 minus x1. So if we find all of these things for this problem, we know that our first x value is 3. So we're just plugging 3 into the equation, should probably use some parentheses here, to be able to figure out what f of 3 is. And beep, 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 calculate in your brain or in a calculator, you would get that f of 3 is equal to negative 4. We do the same thing for the number 5. This would be 5 squared minus 5 times 5 plus 2, beep, 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 brain or calculator, that is 2. Which means that our average rate of change is going to be found when we do 2 minus negative 4 over 5 minus 3. That's easy enough to do in our head. That's 6 divided by 2, which is 3. So our average rate of change is 3. It is just fancy slope, everyone. It is just fancy slope. Next problem wants you to find the derivative of x squared times cosine of x. Now I notice that this is 2 different functions multiplied together, so that means I use the product rule. The product rule is u's and v's. I know I'm going to need the derivative of both of these, so we'll go ahead and do that real fast. 2x and negative sine of x. Now, the product rule says that if I'm using this, it is v, cosine of x, u prime, 2x, plus u, x squared, times v prime, negative sine of x. When we clean this up, we like putting the trig functions second. So this is 2x times the cosine of x minus x squared sine of x, since we multiply by that negative 1. There's my derivative. The next problem asks, what is the relationship between speed, position, velocity, and acceleration? Well, if we remember the position function, if we take its derivative, that gives me velocity. And if we were feeling feisty and we did a second derivative for position, which is really like the derivative of velocity, we would get acceleration. And then last but not least, to toss speed in there, speed is just the absolute value of velocity, because velocity is a speed and direction, which means if you get rid of the direction by absolute valuing your velocity, then you get just your speed. Next problem says, what are the 3 steps for using the intermediate value theorem to justify that a value c exists for f of x on the interval between a and b? Intermediate value theorem is the really simple theorem that has a complicated way to talk about it. The first step in intermediate value theorem is to show that f of x is continuous on the interval from a to b. For most kinds of functions, you just say, it's quadratic. We're good to go. Step 2 is to show that f of a is simply not equal to f of b, meaning that there are 2 different endpoints for your interval, that they are just simply not the same. So we would plug in the numbers a and b and see what we get, just make sure they're not the same. Part C is to finally use that value c that you care about and show that that value c is in between the 2 values you got. Basically, that it is an intermediary between the beginning and end of your interval. If you can do that, then you can show that due to the IVT, there is a value c that exists on f of x on that interval a to b. Last problem here says, write an equation of the line that is tangent to f of x equal x squared plus 6x minus 7 at the coordinate point 3, 20. Remember, if we're trying to write a tangent line equation, we just need an m, an x1, and a y1. Well, they already gave us x1 and y1 here, so the only thing I need is m. Now, we know from studying calculus that if we take the derivative of any function, that's the slope at any point, which is what we need. So we are going to take this f prime of x, and we're actually going to plug in the x value of 3, 2 times 3 plus 6, which is 6 plus 6, or 12. So I have a slope, and I have a point. All we have to do is put in point slope. Y minus y1 equal to m times x minus x1. Voila.